Hey guys, so if you're interested in this enrichment, I'm just going to do the first problem with you from each of the attachments that I have there, and then if you need some additional help, feel free to shoot me an email, or you can just YouTube, graphing quadratics in Vertex Form or graphing quadratics in standard form. Find some other videos, Khan Academy, really anything. So Vertex Form is something that we talked about a while ago. We just didn't use that name when we did transformations. So the technical vertex form of an equation is a parentheses x minus h squared plus k. If you recall the transformations, each of these components do a different thing, okay? So first let's identify those from our problem, and then we'll figure out what they do. So a has to be the number right in front of the parentheses. So in our case, a is 1. H is the opposite sign of the number in the parentheses. So if it's a plus 3 inside, H is negative 3. And that's because in our formula, you see, we have x minus H. So it changes everything to opposite when you put it in. And then K is the number on the end. So in our case, a minus 8. All right. So if you recall, A is the vertical stretch or compression of a graph, okay, meaning how quickly the graph goes up or how slowly it goes up. It also is the reflection of the graph. So if A is positive, your graph faces up. If A is negative, your graph faces down, right? If A is a larger number like 5, then your graph is going to be more narrow. If your graph is a smaller number like a half, it gets compressed vertically, so it becomes wider. I'm not looking for perfection with these graphs here. I just want you to get the general sketch, okay? Minus H, that is, let me get a different color here. That is a horizontal shift. So left and right shift. If it's a positive number, it's going to go to the left. If it's a negative number, it goes to the right. Remember, always opposite of what you see. And then plus K is a vertical shift. So, and these are true to its signs. So if it's positive, the graph goes up. If it's negative, the graph goes down. Okay? So let's deduce what we have here. A was equal to 1, so that means there's no stretch or compression. And if A is 1, that also tells me that my graph is going to face up. So it's going to point up like that, okay? H is negative 3, which means our graph has gone to the left 3. And then K is negative 8, so it's also gone down negative 8, okay? Or down 8 spaces. So if I go to my graph, I'm going to the left, 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8. And I get a point right there, okay? Oops. This point is called the vertex of my parabola. It's where the graph is going to turn, okay? So it's either going to be at the very bottom of our graph, or if it faced down, it would be at the very top, making it a maximum. If it faces up, it makes it a minimum. So if we're writing the point of our vertex, it's just H and K together, negative 3, negative 8. Okay? The axis of symmetry, that's what this represents here, is the line that comes straight through the parabola. It just helps us get some symmetry because all parabolas are symmetrical. That is always the H value, which would be negative 3. Right? And that just means we have this sort of imaginary line that cuts down the middle of our graph. That's what we call our AOS, or our axis of symmetry. And then let's see if we can find another 2 points on this parabola. So if A is equal to 1, we're going to go positive 1. From the vertex point, we always go over one space. Like with a regular parabola, y equals x squared. We start at 0, we go over 1 and up 1. To the left 1 and up 1. And then the next point, we would go over 2, but up 4, because 2 squared is 4. So over 2, up 4, over 2, up 4. We get this lovely parabola, okay? If the a value is not 1, then it's going to cause this graph to stretch or compress. So whatever we normally go up by will get multiplied by the a value. So if a were 2, then we would go over 1 but up 2, over 2 but up 8. If a were 3, we would go over 1 up 3, over 2 up 12. So whatever a is, we multiply it by those second values, those up values. In this case, it's just 1. So from that vertex point, I'm going to go over 1 and up 1 on either side of my graph, over 2 and up 4, over 2 and up 4. And there is my parabola. I'm going to try and keep the curve going so that it crosses the x-axis. And then you can estimate your zeros. So where does it cross the x-axis? The solution's about -6 and 0. So those would be my estimated zeros. Okay, it's okay if they're not perfect. And then you can worry about domain and range if you want. So domain here is, remember with the parabola, is always all real numbers. We're going everything to the left, everything to the right. The range would be everything from -8 on up. So hard bracket -8 to positive infinity. All right, so a lot of the math that we've been doing is sort of all coming together now, but that is how you graph with vertex form. Okay. Again, just keep this piece in your memory. A tells you whether the graph faces up or down. Positive a faces up, negative a faces down. If it is a larger or smaller value, you are going to multiply your up numbers by a. If it gets hard to be too specific, just know if a is a big number, your graph should be narrow. If a is a fraction, it should be wide, and use that to help you sketch your graph. Minus h, so you always take the opposite sign of what's inside the parentheses. That moves your graph left and right. Plus k moves it up and down. If you, at this point, can't fill in all of this business here, then just focus on the graph. Okay, think about, okay, where did it move it? What would the sketch of this graph look like? If you can fill in the pieces of information, that's awesome. So this is how to graph in